annuities. So first I need to define annuity. Let's take an example first. So let's suppose there is a 65 year old guy, and he wants his retirement. So he wants a policy which can pay him $10,000 every year. So suppose now he's 60, so he's 65. So he wants, so when he's 66, so that will be the so he wants a payment of $10,000. When he's 67, he again wants a payment of $10,000, and he wants to keep doing it until he's 80, and then that time also he wants a $10,000. So so he goes to the bank, or he goes to the policymaker, and or the insurance company, or anyone who is selling uh, the annuity, and he wants or asks them that how much money do I need to pay you right now to get this cash flow for the next 15 years. So when it comes to that calculation, we call this arrangement of cash flow as annuities. And then the always the question is that how to calculate the present value of this cash flow in the future. So again, this cash flow, the periodic cash flow of the same amount for next given years is called the annuity. So now let's calculate the present value of this annuity. So first I need to give you an example. So suppose the interest rate is 10%. So if you deposit $1,000 into the bank, then how much it should be after 1 year? It should be 1,000 plus interest, then 10% interest. So 10% of 1,000 is $100. So that will give you $1,100. So that is your amount after 1 year. Okay, if you want to back calculate it, what you have to do is you have to divide the 1100 by 1.1, which is also called 1 plus r, where r is equal to 0.1. Because we have 10%, so it's 0.1. If it's 5%, then it will be 0.05. So if you back calculate it, you can go back and say 1100 divided by 1.1 is equal to 1000. So you can back calculate this way. So now how to calculate the annuity? So now let's go back to the example, and we have payments. So this is our time 0. So let's say t is equal to 0, and this is 1, this is 2, this is 3, this is 4, and our payments are p. So no, there is no payment at the 0, and there is a payment p, 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 and p, right? So how will I calculate that? And the present value, so present value will be equal to, so this we have to get back calculate the first payment for 1 year, so that will be equal to p divided by 1 plus r. Then back calculate second payment for 2 years, so that will be equal to p divided by 1 plus r whole square, and then p divided by 1 plus r whole cube. And then we have to keep doing this and add them together, and we have to do it for 1 plus r is to power n, where n is equal to years of payment, right? So now how do we calculate this? So we can take p as a common, and then say 1 divided by 1 plus r plus 1 divided by 1 plus r square, and then same to 1 divided by 1 plus r is to power n. And if you look at this series carefully, this is a geometric series, so you can solve this by saying p into 1 minus 1 plus r is to power n divided by 1 minus 1 divided by 1 plus r. So this is your value of the annuity. So this is how you calculate the annuity. So this is your present value. Now we can do many other things. So now let's take an example. If we have a annuity, so now I define the annuity, and you have this values, right? And you make a payment. So you make a payment like this: 1 1 1 1 1 and 1. And I told you the value for this is 1 minus 1 by 1 plus r raised to power n divided by 1 minus 1 by 1 plus r, right? So this is your value um, of the annuity, right? So this is the value at this point, right? So this is, I should say, this is the value, right? Now suppose if you want to calculate the future value of this payment, so suppose instead of now taking annual payment, you are giving the annual payment, so you're depositing. So now there is a guy who deposit the money into the bank, so he save $10,000 every year and he deposit to the bank, and then so he making 10,000 to the bank for at the end of, so this is your first year. So he, on the December, he make first payment, and then on the second year he make another $10,000, and he keep doing it for 20 years. So how will we calculate that payment? So for this one we don't have to do the separate calculation. We only have to do is, so we want to calculate the value here. So last time we calculated the value here at this point. Now we want to calculate the value at this point, so at the end of the period. So all we have to do is we have to take this annuity, so 1 minus 1 plus 1 by r is by n divided by 1 minus 1 by 1 plus r, and we multiply this by, because this is the present value, this is the value at t0. So if we deposit this much amount at t0, then it will have an interest of 20 years. So all we have to do is to multiply this by 1 plus r raised to power n, and that will be the value, that will be the value for the future value of the annuity, or the future value at the end of the period. So this is how you calculate the